1, 2, 3. Are we live? Hello and welcome to a new episode of ZomCast number 21. Today we will resume our discussion of classes. This is one episode of Python tutorial series, Classes Part 2, and we will talk about classes. In the previous week, we talked about how to create classes and how we can create classes in Python scripts and how easily we can put some members in those classes. As you can see, we created person class and we put some information. We also talked about instantiating our classes. We created a car class where we could pass in some initial values like model, color, and price, and then we could print them like Volkswagen.model.color or .price, and it would give us those information for that specific car object. Today we will talk about some more advanced topics about classes, like for example inheritance. And for that we will actually look into the classes topic under Python tutorials on python.org. It's website, the official website for Python. So let's go to inheritance section. The inheritance section, and let me show you Firefox. Iterators, no. Inheritance, yeah. Inheritance works by putting a class as the child of another class. For example, in real world, you create a specific car class as a child of another car. For example, let's say the Honda company creates a new series of cars from the Honda family. So we can say that, for example, Honda X, which is a new model of Honda, is created from the Honda family. So it has some characteristics of Honda cars. So we can say that it is a subclass or a derived class from the Honda class. Or a little more close and more realistic example that you can actually touch it more and connect with, like humans. A child is derived class from its parents, like from its mother and its father. So we can say that it's a derived class, and we have inheritance here. This inheritance subject is used in most object-oriented languages like C++, like Java, but something that you need to be aware of is that in Python you can have several parent classes. So for example, you can create an exception class that is the child of several other classes, and we will create a simple exception class that is derived from Python's exception class. So let's now see how it is done, how you define a derived class from a parent class. Imagine your class is base class name, as you can see in this page. It is base class name, and when you want to create a child class from base class name, you enter the child class name here, followed by following the class keyword, which defines the class, and inside the parentheses you specify the parent name. What is the parent name? The parent name in fact, is the class that specifies our parent. And it doesn't have to be only one parent. We can have several parent classes. So in order to add the second parent class or base class, you just add a comma and then the base class name 2, base class name 3, and so on and so forth. Alright. Now, in order to give a more idea of how it works, let's do a real example. Let's create a class and derive it from another class. In fact, let's experiment with inheritance. Let's switch back to Visual Studio Code, and I'm going to create classes part 2. Classes part 2.python script. Let's add some comment in the beginning of the file. This module contains some classes that teaches inheritance in Python. Let's create actually a class, a simple class. Call it number exception. I'm going to create a simple exception class, number exception. That is derived from Python's exception class. So I enter exception inside the parentheses and then colon, and then in the body of the class I enter the definition of the class. Note that when you derive a class from a parent, you need to actually override its constructor and say how it works. And for that matter, for example, for our exception class, we need to make sure that we send a message, because exception needs a message, and we need to do that. We need to pass in that in our child class as well. We need to call that in our child class as well, and actually give that message to the user that some exception has occurred. So in the init one, we have a constructor function that is especially named in Python init, and we pass self, which means this is part of the class and this belongs to the class, and then we pass in the message, which we know is string, str, colon, and super, we pass it to the super message. All right. Method name, let me check. This should be that, this should be correct. Execution of derived class definition proceeds the same way as for a base class. When the class object is constructed, the base class is remembered. This is used for resolving attribute references. If a requested attribute is not found in the class, the search proceeds to look in the base class. This rule is applied recursively if the base class itself is derived from some other classes. There's nothing special about instantiation of derived classes. Derived class name creates a new instance of the class. Method references are resolved as follows. The corresponding class attribute is searched, descending down to the chain of base classes if necessary. And the method reference is valid if this yields a function object. Derived classes may override methods of their base classes because methods have no special privileges when calling other methods of the same object. A method of a base class that calls another method defined in this same base class may end up calling a method of a derived class that overrides it. An overriding method in a derived class may in fact want to extend rather than simply replace the base class method of the same name. There's a simple way to call the base class method directly. Just call base class.method name. This is occasionally useful to clients as well. Note that this only works if the base class is accessible as base class name in the global scope. I remember that I created an exception class, and it worked by passing a message to it. And since this exception actually naturally receives a message, we need to pass in a message for it. But there's something missing here. In fact, it is slightly more complex than the method resolution order changes dynamically to support cooperative calls to super. This approach is known in some other as call next method, and it's more powerful than the super call found in single inheritance languages. Alright, let's try this. For example, let's ask the user to enter a number between 1 and 10. And if they enter something above that range, we throw an exception using our special exception class. So what we do, we first ask the user to enter a number between 1 and 10, and then we line I don't know how to get a number from the user. Input Python read line in Python. We need to read standard input Python input. Yeah, it's input. Actually, it's input. Instead of print, I use input and get the number as input num. And then we check to see if the number is in the desired range. We say if input num is less than 10, less than or equal to 10, and greater than or equal to 1. Oh, it looks like it works actually. Python 2 greater than or equal 1 5. Great, this is amazing. So we don't need to do that using C++ syntax and use AND. We simply put the number in above the starting point of the range and less than the ending point of the range, and it works. Actually, if we say if this is false, if the result of this comparison is false, then it means that we need to throw some exception. We say raise number exception, and we pass in a message. Number entered is not in the accepted range. Okay. Now let's run this. Enter a number between 1 and 5, 1 and 10. 5. Support between instances of int and str. Okay, we need to get the number and cast it to integer actually, because we are getting str, we are getting a string, and we need to convert it to integer. Input. So we do int we cast the value that we get, and then it should work. We are casting it to integer 5, and it's acceptable. Nothing happens. It means that it is acceptable. But what happens if we use a number that is not in that range? Is with a literal. There's some confusion for the Python interpreter. Let's put that. This comparison, this inequality inside parentheses to remove that confusion. Then run this again. 11. Oh, we have an exception. Super argument must be type, not str. Okay. Number exception. Actually, I think even if we use pass inside the body of our number exception, it works, because exception already has defined and implemented the behavior, a normal behavior for handling exceptions, where a message is shown when we enter when we want to throw and raise an exception. All right. Yeah. Let's run this again. Let's enter an unacceptable number like 20, and there we go. We have a number exception, as you can see. So you can simply inherit from a class, from a base class, and you can pass in uh, the information. You can pass in the some variables to it, as long as you know the parent class handles it. And in this case, we knew that the exception class actually handles an exception by showing a message that we specify for it. All right, I'm not a very professional developer in terms of working with Python classes and inheritance. It's a little bit new to me, but I hope that this gives you an idea of how it works. Also, we have multiple inheritance. As I mentioned, you can inherit from several base classes, and for most purposes, in the simplest cases, you can think of the search for attributes. Inherited from a parent class as depth first, left to right, not searching twice in the same class where there's an overlap in the hierarchy. Thus, if an attribute is not found in the derived class, it is searched for in the base, then recursively in the base classes of base 1, and then if it was not found there, it was searched for in the base 2, and so on. Okay, let's talk about private variables in classes, or private members. Note that Python doesn't have that type of complicated access modifiers that we see in C++ and Java. For example, private, protected, and public. Everything in a class is public and accessible and changeable, actually volatile. You can change it. So what happens if you want to have something private? Actually, there's a convention between Python programmers that say if you want to specify something as private in a class, just precede its name with 2 underscores, and it tells Python, not Python actually, it is considered as a convention between developers that this field should be considered private and should not be accessed directly and handled directly. So, however, there's a convention that is followed by most Python code. A named prefix with an underscore should be treated as non-public part of the class. It should be considered an implementation detail and subject to change without notice. Since there's a valid use case for class private members, namely to avoid name clashes of names with names defined by subclasses, there's limited support for such a mechanism called name mangling. Any identifier in the form spam, at least 2 leading underscores, at most 1 trailing underscore, is textually replaced with underscore class name underscore spam, where class name is the current class name with leading underscores. What happened? Where class name is the current class name with leading underscores. Stripped. This mangling is done without regard to the syntactic position of the identifier, as long as it occurs within the definition of a class. Name mangling is useful for letting subclasses override methods without breaking intra-class method calls. Okay. So we now know what name mangling is. It's helpful for letting subclasses override methods without breaking intra-class method calls. For letting subclasses override methods without breaking intra-class method calls. Like for example, in init we have items list, we have update, and then something that derives from mapping. It's named mapping subclass and provides new signature for update. This update changes to something like mapping underscore underscore update. But does not break init. Alright, these are two things that we talked about regarding classes this week: the inheritance and also the private members. If you want to create a private member in your class, just precede its name with a single underscore, not double underscore, only one underscore, and it's enough. All right. Before we wrap up this week's ZomCast, let's talk about some of the events that occurred in this week. Last week, we had WhatsApp controversial policy update that caused a lot of outrage, and looks like a lot of Europeans have switched to Signal for the issues that the policy created. And that policy update actually concerned a lot of people regarding to privacy, and in social media some people were saying that even mark as read, that means marking a conversation as read is better to be read as, is better to be said as something like Mark has read. Mark Zuckerberg, they mean. And another thing that we had regarding the Android world, we had update about Compose, Jetpack Compose. If you go to Jetpack Compose website, developer.android.com/jetpack/compose, you will find there was another. Now you can upgrade your Compose projects to 1.0.0. Okay, now you can update your Compose projects to the latest version 1.0.0 Alpha 10. Okay, guys, I hope that you liked this week's ZomCast number 21. Please like and subscribe, and see you next week.